Hello everyone. So welcome to my YouTube channel and in this STL playlist series where I discuss tips and tricks for beginners and advanced people on how to apply STL in coding interviews and in contests. So today we are going to find out today we are going to just see how are we going to find out the maximum element which are present in set and map data structure. So there's So let us say we have a, first of all, let's define set and insert the elements. So, so I've inserted all the elements in this vector. Whatever elements are there in this vector, I've inserted them. Now let's try to print all the elements of this vector in this set. So if you see, the elements in the vector were like this: 4 1 3 5 7 9 11, and in the set it is stored in sorted order: 1 3 4 5 7 9 11. It's in sorted order. So what if somebody asked me to find out the maximum element in the set or minimum element in the set? So you should remember that a set is not indexed. Like, you cannot say that set dot, if you do s0 or if you do s1 you will find out the maximum element or the minimum element, right? Since that is not indexed, we can't use indexing. So we have to use the concept of pointers. So let me just copy paste this. So internally set would be something like this. Wait, okay, I think I have to type it manually. 5 7 9 11. So we have two pointers. The first in is s dot begin and the second one is s dot end. In fact, we have four of them, and we'll see them one by one. So where does s dot begin point? S dot begin points to the first element in the set. That is, s dot begin points to 1. Keep in mind that I'm saying that it points to 1. It does not mean that it is equal to 1. And we'll see how we are going to use it. And s dot end basically, so s dot begin is pointing to this one element, and s dot end would point out to the element which is just outside the set. So it's not pointing to 11. This is very important. S dot end would point to an element which is outside the set. Okay, so let's say something else. So if we have to find out the minimum value, what are we going to do? Since it's a s dot begin points to the first element, we can dereference it and just say s dot begin min element. Okay, let's try to run this. Okay, okay, so we can see that the minimum element printed here is 1. Let me format it a little. Yeah, so the minimum element is present is 1. Now how are we going to find out the maximum element, since we don't have an access to the maximum element by using this end pointer? So do you think that we need to traverse the whole set to find out the last element? Actually, in C++ we have two more additional pointers which are given for our convenience. So it's called rbegin, reverse begin, begin, which points to the last element, and then we have s dot r end, and again, just like the last one, it does not point out to the first element, it points out to the element before the first element. Okay, so think about it. What are we going to use to print the the maximum element? Pause the video and think. So it's nothing but as dot r begin. As you can see that as dot r begin points to the last element and it's the maximum. And since the set is ordered, the last element is guaranteed to be the maximum one, right? So let's try to print this. Let's compile. Okay, it will throw error because of this. So the minimum element here is 1 and the maximum element is 11. Okay, and you can do something similar in maps. So map is also a data structure which is internally represented as a balanced binary search tree. So you can do the same thing. One question I have, it's like a follow-up question. You can think of it first of all and then answer. Can we do the same thing what we have done in for unordered set? Think about it. I'll give you a minute. You can pause the video and so it's actually in the name. It says that unordered. You see, it's unordered set. So the moment you try to insert in this unordered set, there is no guarantee that it will be uh, ordered by any chance. Like it might be okay. Let's just run this and see what it is going to print. Okay. Wait. Yeah. So if you see the the if you see that the elements of the unordered set are like this 11 9. So these were the elements in the vector 4 1 3 5 7 9 11, and these after inserting in the unordered set we get something like this 11 9 7 5 3 1 4. So this is not, it's neither decreasing nor increasing. Like you can see that it's increasing here and it's decreasing here, so there's no order as such. And you can see that minimum element is 11. And in fact if you do r begin is not even defined for the unordered set. Yeah, you can see, did you mean class unordered set doesn't has no member named r begin. So I hope this was useful for you guys. You can try the same thing for map and post a solution in the comments. Okay, I will give you, I'll give you some hint. Wait a second. So okay, I shouldn't have done that. So if I have something like mpx plus plus map integer, now think about what would happen. Like change this loop won't remain the same. Change this loop and find out the minimum and maximum element and let me know in the comments.